Welcome everyone, my name is Craig Otto. This is Statistics for SPC, Operational Excellence. Today we're going to talk about permutation and combination. First of all, when I say permutation and combination, what I'm talking about are event series, and they're basically counting rules. The first is permutation, so I'm looking at the number of ways to arrange something in order with n distinct objects, taking them r at a time. That's known as NPR. Okay, so it's basically looking at combinations where order matters. You know, the number of combinations, and we'll look at examples here in a minute to help you better understand what I mean by that. The second counting rule is combination, but this is where order doesn't matter. You're just looking at how many combinations are there of n objects taken r at r times, and that's called NCR. And there's a lot of it's not real complicated, but it gets pretty complex math behind all this. So being that this is just a basics statistical course, sort of an introductory, I'm not going to get into that, but as my high school math teacher always says, we're going to just push the button and out comes the cookie. So in other words, we're not going to know the meat and potatoes, how the calculator is calculating these things, but we are going to know that when we have a problem, we know that we can go to the calculator and calculate this out. So again, I mentioned NPR is kind of the way things are stated, and on the calculator, let's say they give an example: how many permutations of 2 cards can be chosen from a deck of 5 cards? So your NPR would be, you have n samples or 5 samples, so it's 5. P, now where you get the P is, so you enter 5 on your calculator, and then you hit the math button, go to the PRB for probability, then press the second one, or you can scroll to the second one. And what it'll do, it'll put, so you typed 5 on the screen, you went in, you got the NPR, you hit enter, or number 2, and it'll spit out 5 NPR, and then you actually have to input 2, so 5 NPR 2, meaning, you know, the two cards can be chosen from the deck, 5. So it'll spit that answer out as 20 possible permutations with that situation. So your answer would be 20. That's how many permutations there are. So let's continue on. Again, that's where order matters. Here's some more examples, and keep in mind, using your calculator or Excel, you can do the same calculation in Excel. I try to, you know, put that information on here for you. The first one is, how many seating arrangements of 8 people can be made around a dinner table? In this case, it would be 8 P8, because there's 8 seating arrangements, and they want to know how many, you know, there can be. And in this case, order matters. Second example, how many ordered seating arrangements? There you can actually, it actually says it, how many ordered seating, so order matters, arrangements of 8 people and 5 chairs. So it would be 8, because there's 8 people, P 5, because there's only 5 chairs. If you type in Excel or calculator, it should work for both. You can see here I got Excel, it's permute with a parenthesis 8 comma 5 end parenthesis. Make sure you get your equal sign in there. It won't work if you don't have equals. And then on the calculator, you just hit 8, and then you go into your math probability, NPR, and then enter your 5, and you should get 6,720 arrangements. That's if order matters. Let's do another example. There's an executive board of 15 people. The board will select a president, a vice president, and a secretary. Determine a number of different ways the members can be selected. So the first question you have to ask yourself is, does order matter? And it does, because if the first person you select they're either going to be a president, a vice president, or a secretary. Whereas if I said, it would be maybe like representatives, where there's no distinguishable difference between the members. See, in that case, it would have been a combination. But because we have these three different things, president, vice president, secretary, that means order matters. So we're going to use permutation. So when you plug it in, it's 15p3, and then you get 2,730. General rule of thumb, it's always going to be, if you're not sure, how do I know it's not 3p15? Well, general rule is it's always the bigger number first, because you're trying to you have your sample, which is always the biggest, and then you're trying to determine how many different ways can be selected. So usually it's always the bigger number first. There are 3 engineering openings: engineer, senior engineer, and engineering specialist. Out of 6 applicants, how many ways can that be filled? And again, order matters. There's a difference between engineer and engineering specialist. It does, whereas if it just said there's 3 engineering openings where there's no distinguishable difference, it's an engineer is an engineer is an engineer, then in that case it would be a combination. But because we have 3 different variants of engineers, now it matters. That's why it's permutation. So when you calculate it out, it comes to 120 different ways that the opening could be filled. Okay, so let's talk about combination now. Basically, it's entered on the calculator almost the exact same way, only instead of choosing option 2 here, you're selecting option 3, which is NCR, for combination. And again, this is where order doesn't matter. Okay, so let's get some examples. You have 10 finalists in a cash now lottery system. 3 of the finalists are selected as equal winners of the cash. Now, right there, that tells you order doesn't matter because they're equal winners. Now, if you had a first place where they got more, that would be a permutation. But because it's equal winners, it's combinations. So how many combinations can be drawn in the lottery? So again, you have your 10 finalists, so it's 10C, and you have 3 of the finalists being selected, so it's 3. 10C3. Enter that on the calculator or plug it in Excel as equals combin, and then put your 10 and 3 in, and it should spit out 120. Second example, how many ways can a committee of 9 select 4 trustee members? See, a trustee is a trustee is a trustee, so there's no difference between them. So order does not matter. Whereas, before, a similar example to this was we were selecting a vice president, a president. That's the difference. Here, a trustee, order doesn't matter because they're all equal in terms of position. So when you type it in, it's combination 9, which is from here, 9 from the committee. We're selecting 4 trustees, so it's 9C4. Do it again on Excel or calculator. Should come up with 126 different combinations. Alright, next, in a round robin tournament of 6 teams, only the 2 best teams can advance. So those 2 best teams are equal. The order of those 2 doesn't really matter. You just got to get to that point where you can advance. So how many different ways can the teams advance? It would just be 6 because of the 6 teams. C2 because there's only 2 that can advance, and that should come up to 15 different ways. Okay. There are 347 Division I schools, and the NCAA basketball tournament selects 68 of those teams to participate in their tournament. How many combinations are there of teams making the big dance? Alright, so the way you figure this out, you have 347 schools, and we're asking how many ways can they make it. And what that's saying is it doesn't matter if you're selected as top seed or the 68th team. They just want to know how many combinations so that you make it. So that what you do is it's 347. Order doesn't matter. You just got to make it. So 347 combinations, so C, and then 68 teams. that you're selecting. And it should be a huge number. So there's a bunch of combinations when it comes to the teams making the tournament. 1.9 times 10 to the 73rd. So there's a lot of combinations. Okay, that represents everything I wanted to go through for now with permutation and combination, and we'll get into, as you see, Poisson and binomial next time.